So the question that we've got here is, imagine that you've got sticks that are all of exactly the same length. And they're wondering how many different sorts of triangles, or what do the triangles look like if you've got 4 matchsticks. I'm not going to do this exactly, but because I'm not going to draw them all up. But let's say that we've got 4 sticks that are all exactly the same length. 1, 2, 3, 4. And I tried to make a triangle out of this. Well, I couldn't. I could if I had 3. I'd get a nice equilateral triangle with all of the angles here would be 60 degrees. But if I've got 4, let's say that I use 2 on the bottom, and then I use 2 on the top, doesn't matter where I put these 2, it's never going to meet the middle to form a triangle. The only way that these 2 can go on the top and touch one another is if they go directly over one another like that. So they'll never be able to build a triangle. So when I've got 4 matchsticks, the answer is no triangles. I can't build any triangles with 4 matchsticks that are all exactly the same length. Okay, because that's the only way I could put them so that they were all sort of touching. I can't get any angle there, so I can't make a triangle. So that's the first one. And then the next question was to do it with 5 triangles. Okay, well 5 is a little bit easier. 5 matchsticks. Because now I could put 2 here and 2 here, and then I could have it tall and thin with 1 in the bottom. So what sort of triangle am I making here? I'm making an isosceles triangle. Okay? Isosceles triangle is what you call leak bait. This is what we could make with 5 sticks. And that's really the only way that we could make that as well. What about then, the next one was it 7 sticks? 7 sticks. Well, with 7 sticks, I could do an even taller, thinner. Have to be even thinner than that. And 1 down here at the bottom. So again, it's exactly the same. It's an isosceles triangle that I can make easily from 7 sticks. But then it came and asked us, what about if you use 12 sticks then? Well, with 12 sticks, I would have 1, 2, 3, 4. 1, 2, whoops, a bit too wide maybe, sorry. 1, 2, 3, 4. I'd have 4 sticks on every side. So what do I get then? Now I don't have an isosceles triangle, I have an equilateral triangle. What do I know about the special properties of an equilateral triangle? Well, these angles will all be 60 degrees. All of the lengths of the triangles will be the same, whereas in these isosceles triangle we'll only have 2 lengths that are the same. The longer lengths of the triangle will be the same. But I could have also done it that I drew this one with 5 here on each side. 1, 2, 3, 4, 5, and then put my 2 that were left over on the bottom. So I also, not only could I have drawn an equilateral triangle with 12 sticks, I could have drawn an isosceles triangle with 12 sticks. So by investigating this, you can see that for 4 matchsticks, there's no triangles possible. For 5 matchsticks, you can get an isosceles triangle. For 7 matchsticks, you can also only get an isosceles triangle. But for 12 matchsticks, you could get an equilateral triangle and an isosceles triangle. And they wanted you to investigate this. So go home, play with matchsticks. Take 9 and see what your triangles look like then. So it's all about sort of trying to improve your understanding of how we can make triangles with objects that have the same length and what actually happens then. It's a